Last week, I was sitting in this minimalist boardroom in Palo Alto, and I'm with a startup founder who is just completely convinced his new AI-integrated smart grid is going to revolutionize the West.
Right.
He was leaning over the sleek white prototype, and his eyes were bright with that, that classic Silicon Valley fervor. He kept saying, "We're bringing the brains back home," tapping on the casing. For him, it was this ultimate symbol of American ingenuity, a piece of hardware designed, branded, all in the USA.
Mm-hmm.
And he's talking about disruption and innovation with this religious certainty that you really only find in people who haven't looked at a technical manual in years.
I know the type.
Exactly. But then I just asked a simple question. I said, whose protocols are these sensors running on?
And the room went silent.
Oh, completely quiet for a second. He pulls up the technical specifications on this massive 8K screen, and we're scrolling, through the deep layers of the device's architecture. And as we get into the weeds of the data encryption, the high-speed communication layers, a recurring code keeps popping up in the footnotes.
A standard.
A series of international standards, finalized just this year. And I watched his expression just shift from this immense pride to a sort of glazed confusion. He realized that every critical joint in his machine, how it talks, how it thinks, how it secures itself, was built on a foundation of 275 new standards.
Wow.
All proposed and led by teams in Beijing and Shenzhen.
So he's not the architect.
He thought he was, but he was really just an interior designer picking out the wallpaper for a house somebody else had already built. He had the brand, but he didn't own the grammar of the technology itself.
That's a powerful way to put it.
And that silent realization in that California boardroom, it's the perfect autopsy of the modern global power shift. While we've been distracted by, the theater of identity politics and the highs of the stock market, the tectonic plates of civilization have moved. It's not about who builds the gadget anymore.
It's about who writes the rules that the gadget must follow to even exist.
Precisely. By taking the lead on 275 international standards in 2025, China hasn't just won a trade war. They've begun legislating the physical reality of the future. The factory of the world has officially graduated. It's become the legislator of the world.
Right.
And the implications for our technical sovereignty are, they're far more permanent than any tariff.
And the profound shift in power
Right.
from making the things to making the rules for the things, that's exactly what we need to dig into today.
Yeah.
We're going to do a deep dive into that, a hidden infrastructure of global influence. We're looking at this correlation between having a massive industrial output and how that leads to dominance in these international technical standards.
So it's the ultimate high-level strategy. It feels like our traditional ways of measuring geopolitical power, military spending, GDP growth, they're really only telling half the story.
They're becoming lagging indicators in a way. The ability to define these technical protocols, well, that's the new foundation. It's about economic and, you could even argue, civilizational sovereignty.
Okay, so that really clarifies the mission for this deep dive. We need to unpack this whole process. We have to understand the precise method behind this transition from being the world's workshop to becoming its technical rulemaker.
Exactly. How do these seemingly dry, tedious technical protocols become the new bedrock of global influence? And maybe more importantly, how is institutional capacity the engine that's driving this whole standards war?
Let's do it. Let's start by defining the battlefield itself. Okay, so let's unpack this and define the terrain. Because when we say technical standards, I think most people's minds go to, USB plugs or Wi-Fi passwords, but we're talking about something far, far more foundational to the global economy, aren't we?
We really are. The international technical standards we're talking about, they form the basis of a global governance framework. They are the agreed-upon norms and procedures for how technology operates, how it communicates, and how it secures itself.
So they're the universal language.
That's a great way to think of it. If a device wants to be integrated into the world economy, and it doesn't matter if it's an AI module, a high-speed rail network, a new cellular antenna, it absolutely must comply with these rules. There's no choice.
So if a company wants to build a new smart car, they don't just get to decide on a whim how that car talks to the traffic lights or to other cars.
No, absolutely not. The standards body has already set the language for that conversation.
Okay.
They establish interoperability, safety requirements, performance benchmarks. But here's the crucial geopolitical shift we're seeing. This sphere, which was traditionally the domain of, engineers and specialist working groups.
Backroom stuff.
Exactly, backroom technical discussions. That has now become the new battlefield for state influence. There's a really clear, steady rising trend of active state participation in setting these global standards. It's not a technical discussion anymore. It's high-stakes foreign policy.
So what's the foundational requirement for a state to even get in the game, to successfully enter this standards battle? You can't just show up and say, we have a new idea.
No, you can't. The price of admission is technological self-sufficiency. You cannot convincingly argue for your standard to become the global norm if you don't possess the industrial capacity, the expertise, and crucially, the patents to manufacture that technology yourself.
And at scale.
And at massive scale. If you're reliant on other countries for the core intellectual property or the complex components, your leverage in that standard-setting discussion is basically zero.
So the decades of industrial mastery, that was the prerequisite. That was the entry ticket to becoming a standards legislator.
It reframes the whole economic story. Those decades spent mastering supply chains weren't just about making things cheaper. They were about gaining the deep institutional knowledge you need to eventually control the knowledge transfer itself.
And now this ambition has been formalized. It's not just happening organically. There's a proactive national blueprint.
Right. And that plan is the Standards 2035 project. It's a massive strategic campaign designed to achieve global dominance by essentially exporting Chinese technical standards.
What's the driver?
It's driven by a clear recognition of the immense political and, of course, economic value that's embedded in these seemingly minor technical agreements.
So what makes them so valuable economically that they're worth a massive national campaign like this?
It's a fundamental shift in where you capture the value in the global economy. For decades, the economic model relied on volume, right, being the factory of the world, maximizing bulk exports. But that model is getting old. As a share of GDP, bulk exports are declining. Standardization is the key to optimizing the massive manufacturing industry that's left, and more importantly, improving the overall economic returns.
So instead of earning, a few pennies on the assembly of a phone, they want to earn dollars on the license for every phone made anywhere in the world.
That's it exactly. The shift is from earning assembly fees to securing massive economic gains through licenses and royalties on intellectual property. Think about it. If a Chinese firm's specific approach to, say, electric vehicle battery management
Or quantum encryption.
Yeah. If that becomes the mandated international standard, then every single company that implements that standard anywhere in the world owes that firm royalties. It's a mechanism for continuous global wealth extraction.
Which means the standard setter gets the ultimate first mover advantage. You control the baseline for the entire technological field from then on.
You absolutely do. This control lets you dictate the pace of innovation. It means future technological growth is now subject to your specific patent approvals and your licensing terms. It pulls the entire ecosystem into your orbit.
You're no longer the downstream assembler. You've become the upstream rule maker.
A complete inversion of the old model.
Okay, so where is this strategic ambition formally outlined? What's the document we should be looking at?
It's all detailed in the official 2021 blueprint. It's called the National Standardization Development Outline, or NSD. This is the central policy document for the entire initiative.
And what are the specific objectives the NSD lays out?
It has three main goals. First, promoting high-tech innovation. Second, facilitating the opening up of their technology sector to the global market. And third, and this is the most important part, achieving what they call high-quality development.
And high-quality development is basically code for?
It's code for moving beyond high-volume, low-margin production and into high-value intellectual property and high-tech manufacturing.
I'm guessing it's not focused on things like toaster ovens. What are the specific technologies being prioritized?
No, definitely not. The outline explicitly focuses on improving technical capabilities and raising IP levels in critical future-shaping technologies. We're talking about the cutting edge. Artificial intelligence, quantum computing, advanced materials, and of course, electric vehicles and smart manufacturing systems.
And the strategy is two-pronged.
It's a dual strategy, yeah. They need to ensure these standards are robust enough for domestic adoption across their own massive economy first. That's the testing ground. Then, they simultaneously develop them specifically for international export and, ultimately, dominance.
Now, the document also mentions a significant shift in approach. It talks about moving toward an industry-led model for standardization, away from a purely state-centric one. Why would they do that? Doesn't that kind of dilute the central control?
It seems like it would, but it's actually a very sophisticated maneuver.
Yeah.
Historically, a purely state-centric standardization process can be bureaucratic and slow. Sometimes it even lags behind what's actually happening on the ground with technology.
Right.
By moving toward a private sector or industry-led approach, they can harness the dynamism and the deep expertise of giants like Huawei, ZTE, and others who are actually on the technological front lines. It means they get faster, more realistic, more effective standards proposals.
But the state still holds the reins at the end of the day.
Critically, yes. The party state retains the final veto and the overall directional control over the outcome. They're essentially using the private sector as a knowledge engine.
A research and development arm.
Exactly. But the final standardization strategy absolutely has to align with the broader national geopolitical goals and the economic roadmap laid out in plans like Standards 2035. It's a very efficient blend of private innovation and centralized strategic direction.
And that level of state capacity to mobilize private expertise while keeping that central control, that feels like the key difference, doesn't it? It allows them to coordinate resources on a national scale that other systems might really struggle to match.
It's the core advantage. Success in standardization requires a unified national effort, deep technical resources, and the credibility that can only come from immense industrial scale. And that industrial scale, well, that's what we need to unpack next.
Okay, let's move into the engine room then. Because it's one thing to have a plan like Standards 2035, but you can't write the rules for something unless you've already proven you can build it better, cheaper, and more reliably than anyone else, and do it at a staggering scale.
Right. Standard setting requires proof of concept and, just as importantly, proof of mastery.
And the statistics on this industrial capacity are they're hard to comprehend.
They are truly staggering, and they represent decades of disciplined accumulation. Let's just look at the electronics sector alone. From 1990 to 2021, China's electronics exports surged from, what, a mere $5 billion?
$5 billion, yeah.
To roughly $1 trillion.
A trillion. It's not just large, that's globally dominant.
It is. $1 trillion in electronics exports by 2021 surpasses the combined electronics exports of the next 5 leading nations put together.
Wow.
And even with all the talk now about supply chain fragmentation, finished electronics exports from there still represent this enormous fraction of global trade in those goods. That kind of scale gives you a sheer gravitational pull that forces the world to consider adopting your industrial protocols.
And the analysis we're looking at suggests this isn't some sudden miracle that just happened because of economic policy in the 1990s. It's framed as a reactivation of a much deeper historical strength.
That's a critical perspective to have.
Yeah.
It's framing this success not as some kind of historical anomaly, but as a return to a civilizational strength in applied technology, in diffusion, and in practical engineering.
What do you mean by that?
Well, for much of human history, before the 17th century, large parts of Asia were leaders in these exact domains. The invention and systematic refinement of paper, printing, gunpowder, the magnetic compass, these weren't just flashes of genius. They represented a consistent, deep capacity for technological application and diffusion across a vast geography.
So when the economy reopened, they were reactivating an existing institutional muscle for absorbing, adapting, and extracting maximum efficiency from technology, rather than, say, starting completely from scratch.
Exactly. And that makes the learning curve argument so powerful. Think about the early phase of high-volume manufacturing, like assembling the first iPhones.
Right. The stories about them earning just a few dollars per unit.
Right. Early on, firms were often earning just a few dollars for basic assembly, but that experience was not wasted. Through continuous, systematic process mastery, often involving ferocious domestic competition and a disciplined focus on eliminating every little bit of waste, those firms rapidly gained the capability to move up the value chain.
Can you give us a concrete example of that? How they moved up the chain?
Sure. Initially, they were just putting foreign-made components together. But mastering the process allowed them to start supplying increasingly sophisticated and critical inputs themselves. They moved into complex areas like specialized connectors, high-precision molded casings, advanced batteries.
And eventually, even things like the high-resolution touchscreens.
Exactly. The ability to guarantee quality at massive scale, that's process mastery, is what allowed them to displace foreign suppliers for those really sophisticated inputs.
It sounds like a completely different metric for success than what Silicon Valley often focuses on. It's not about the one initial brilliant idea. It's about the perfect, relentless execution of that idea millions and millions of times.
That's the core insight right there. That disciplined efficiency, that ferocious competition, and the systematic cultivation of human capital. These elements create the industrial credibility you need. The ability to execute a process perfectly, millions of times over, is what gives you the authority to dictate the global protocol for that process.
But that level of precision across an entire industrial base requires a massive, technically capable workforce. Where does that knowledge base even come from?
It's rooted in education, specifically widespread applied numeracy.
So a mastery of practical math.
Yes, the foundational mastery of mathematics that's necessary for complex technical work. And the performance data on this is really telling. If you look at the PISA assessment scores for 15-year-olds in key East Asian nations, Singapore, Japan, Korea, they consistently score far, far above the OECD average in mathematical literacy.
And how does a high PISA score translate directly onto a factory floor in, say, Shanghai? What's the connection?
It means the workforce has the necessary foundational problem-solving skills for modern manufacturing. We're talking about things like statistical process control, which relies heavily on applied statistics,
Correct.
Or troubleshooting complex firmware and equipment, which requires logical deduction, or just the ability to read and master incredibly detailed technical documentation, which is often translated or adapted from foreign sources. When you're running automated lines, your efficiency gains rely on meticulously tracking and reducing tiny variances.
And you can't do that without the math skills.
You can't. If a worker can't reliably apply statistical modeling to manage yield, they can't optimize an automated production line. The sheer density of technically literate workers is what makes continuous small-scale process improvement possible across the entire industrial base.
So if the workforce can handle statistical process control, that enables those compounding efficiency gains you hear about.
Exactly. Automation is integral to this entire method. When your production scale is immense, even tiny yield improvements, increasing output efficiency by 0.2 of a percentage point, that can translate into savings or gains worth millions of dollars a year.
And automation makes that possible.
Automation confirms and maximizes the efficiency gains that come from that technical competence. It's why nations like Korea lead the world in robot density, with China and Japan not far behind.
Okay, but this systematic approach needs fuel. What about R&D investment? Are we just talking about throwing money at basic science?
No, the R&D investment strategy is highly pragmatic. It's deeply integrated with industrial policy. You have nations like Korea investing roughly 5% of their GDP in R&D, which is one of the highest rates in the world. And while China's intensity is a bit lower, maybe around 2.68% of GDP, the sheer aggregate spending is now narrowing rapidly toward U.S. levels.
And the focus isn't just on discovery, but on converting lab output into tangible capabilities for suppliers. How do they make sure that knowledge actually diffuses through the economy instead of just sitting in university journals?
The strategy prioritizes the diffusion and spread of existing knowledge. It's all about implementation. They use key mechanisms like establishing shared metrology labs, which ensure precision and standardized measurements across a complex network of thousands of suppliers.
So everyone is using the same ruler, literally.
Exactly. They also create university industry consortia dedicated to solving specific applied problems. The goal is to create an infrastructure where companies can, quote, copy legally, adapt quickly, and eventually originate selectively.
It sounds like they measure R&D success not by the number of Nobel Prizes, but by the number of local companies who successfully integrate new knowledge into their production lines.
That is a perfect way to put it. The emphasis is on tangible process improvements and creating what they call cycle time confidence, the assurance that a firm knows exactly how long a reliable process takes and can promise delivery dates with high accuracy.
And all of this systematic, process-driven efficiency is the absolute precondition for something like the Standards 2035 campaign to even have a chance of succeeding.
It is. Without this foundation of scale and skill, they would have zero credibility in those standards organizations.
Okay, so once you've built that overwhelming industrial and educational capacity, the focus then shifts. It moves from the factory floor to the international diplomatic tables. You have to win the standards war explicitly.
Right.
Let's talk about securing seats at the table, these standards developing organizations, or SDOs.
SDOs are the international bodies that actually draft and approve these crucial technical protocols. Historically, they were largely dominated by Western influence. We're talking about groups like the International Organization for Standardization, ISO, the International Electrotechnical Commission, IEC, and more specialized groups like 3GPP for mobile telecommunications.
And what we're seeing now is a fundamental shift underway in the leadership and the composition of these groups.
Absolutely. And this shift is not accidental at all. It's the result of a deliberate, long-term strategic placement campaign. The strategy involves successfully increasing the number of highly expert officials, technocrats, and private sector leaders within the key working groups and committees of these SDOs.
And it's not just about having a body in the room. You need deep technical competence that commands respect.
You have to bring the expertise. And the most visible example of this strategy in action is definitely in the telecommunications sector.
5G technology.
Yes, 5G is the prime example. Companies like Huawei and ZTE, having invested immense amounts of money and demonstrated huge capability in 5G infrastructure, actively position their representatives. Key individuals from these firms have been elected as chairman and deputy chairman of 3GPP,
which is the body that establishes the global standards for all mobile telecommunications.
for everything. So when your experts are chairing the working groups, you are in position to shape the conversation from the ground up, aren't you?
It must create significant contestation over how standards get established.
It does. The simple act of chairing a working group lets you set the agenda, manage the discussion flow, and decide which proposals get priority review. And crucially, it lets you define the technical baseline for the next generation of standards, like framing the foundational concepts for what will become 6G.
It's soft power, but leveraged through pure, undeniable technical expertise.
Exactly. And the ultimate payoff for winning this standards battle is locking in those intellectual property rights we talked about earlier.
The ultimate prize.
That's it. If your proprietary method or application becomes embedded as a required component of a ratified international standard, you've just created what's called a standard essential patent, or an SEP.
And that grants the company or the state the IP rights over certain applications, forcing every competitor in the world to get licenses and permissions.
Right. It's essentially establishing a global intellectual property tax on a specific technology domain.
So is it a free-for-all?
Not quite. SDOs typically operate under what are called fair, reasonable, and non-discriminatory or FRAND licensing terms. But the mere existence of that requirement means mandatory royalty streams flow back to you. The system ensures standardization becomes a quid pro quo. If you want access to the global market, you must adhere to the rules.
And if those rules are backed by Chinese IP, you pay a license fee.
And you leverage the economic benefits from decades of industrial scale into a permanent royalty income.
Okay, now let's follow the strategy as it moves out into the world. The focus shifts from just influencing the SDOs to integrating technology dominance directly into foreign policy. This is where the digital Silk Road comes into the picture.
This is the concept of exporting the grammar.
Yeah.
You're integrating technology dissemination into premier foreign policy projects like the Belt and Road Initiative, or BRI.
And the digital Silk Road is the tech component of that.
Exactly. It's the part of the BRI that's dedicated to exporting digital infrastructure, everything from fiber optic cables and mobile networks to operating systems and smart city systems to partner countries.
And along with the physical networks and hardware, they're exporting the technical standards that they've championed back in the SDOs.
That's the package deal. They export the accompanying technology standards to BRI partners, which often have less developed digital regulatory frameworks of their own. And this is particularly visible across the African continent.
Africa seems to be a major case study in how quickly these standards can be adopted, especially when there's an economic incentive. Why are they being embraced so rapidly there?
It's driven by really practical economics and efficiency.
Yeah.
Huawei and its components make up nearly 70% of the total 4G networks across Africa.
70%.
And they are building major high-capacity data centers in key regional hubs like Ghana, Nigeria, and Egypt. The low installation costs and the extremely attractive running costs offered by Chinese tech firms significantly lower the barrier to technology acquisition for developing nations.
So it's the path of least resistance.
It's the path of least financial resistance. When an African nation needs to rapidly build out its digital infrastructure to support a growing economy, the package offered hardware, software, and standards all in one is often the most compelling option.
And that widespread, rapid adoption embeds their standards as the default operating system for an entire continent's digital future.
It does. It often mitigates political concerns because the technology is affordable, it works well, and it's available now.
It's a brilliant technology diffusion mechanism. You embed the standard by making the compliant technology the most competitively priced, efficient, and readily available option. So let's zoom back to Beijing. This entire global undertaking, from the math scores in schools to the data centers in Africa, it must require immense central orchestration.
It requires a level of state capacity and continuous mobilization that very few nations can match. There has been a relentless campaign over the last 30 years to marshal technical standardization nationwide. This gives Beijing a high degree of state control over its vast manufacturing machine, which allows for quick, unified action.
And that high degree of national coordination is what positions them to influence global supply chains in a way that others just can't.
It provides the leverage.
Yeah.
The state-centric approach ensures that the definition of standards is tied directly to national strategy. Now, it's not purely top-down, as we said, with the shift toward industry-led standardization.
Right.
But the party state is absolutely involved in every step of the decision-making. The final overarching policy direction must align with national geopolitical and economic goals.
What else does that control enable?
It also allows for a really clear distinction domestically between mandatory and voluntary standards. The mandatory standards are crucial for ensuring quality, security, and interoperability across their vast domestic market. That market acts as a powerful testing ground. And once a standard is perfected and scaled internally, its export potential and its chance of winning at the SDO level is just significantly higher.
Okay, so we've traced this path of dominance from the national strategy, Standards 2035, all the way down to the industrial foundation, the applied numeracy, the R&D, and then out to the geopolitical execution with SDOs and the digital Silk Road.
Right.
But now we have to address the deep structural question, which is, why is one system apparently so much better at generating and exporting this grammar than other systems might be?
And this is where we really have to get into governance philosophy. The standards race, in a way, reflects a competition between two systems of order. The ultimate shift in global power dynamics is moving away from systems that emphasize Western procedural democracy, which are focused on checks and balances, to systems that emphasize efficiency, long-term planning, and unified execution.
And the ability to define these international technical protocols serves as the new benchmark for civilizational sovereignty because it requires that rapid, unified national effort.
That's the absolute crux of it. The analysis here rests on this narrative of systemic supremacy. The political system is presented as highly efficient, centralized, and based on meritocratic performance evaluation, which gives it what's called high-state capacity.
Define high-state capacity in this context.
It's the institutional ability to mobilize national resources, to execute complex, decades-long plans, and to adapt rapidly to technological changes without getting bogged down or stalled by internal political dissent or gridlock.
And that concept of high-state capacity is often contrasted with what political observers call vetocracy or gridlock in Western systems.
Precisely. Vetocracy is a term used to describe a governance system where there are just too many checks and veto points. You have independent legislatures, powerful regulatory bodies, competing interest groups, short electoral cycles, all of which make it incredibly difficult to execute large, sustained, long-term industrial policies.
We see that friction in everything from trying to build new infrastructure to trying to fund next-generation R&D that doesn't have an immediate political return.
The comparison is really stark. The centralized model, through its unified executive control, can dictate funding priorities, it can coordinate academic research with industrial demand, and it can quickly mobilize its national champions to bid for those SDO chairmanship roles we talked about. The execution speed and the consistency are maximized.
Whereas a system with deep checks and balances is prioritizing deliberation and preventing the abuse of power, which is a noble goal, of course, but it inherently sacrifices speed and strategic coherence.
And speed and coherence are vital in a fast-moving technical race like this one.
It's a trade-off.
It's a fundamental trade-off. The system that prioritizes checks is resilient and stable, but it's often very slow to adapt its large-scale national strategy. The system that prioritizes centralized efficiency maximizes its capacity during periods of intense competition or crisis. And that allows for the kind of rapid technological mobilization and standardization that we've been discussing.
So to win the standards race, you need consistency. You need the ability to fund research and industrial scaling over decades, regardless of who is in office.
Exactly. High-state capacity allows for this long-term planning. It effectively connects the political structure directly to that industrial efficiency engine. The unified executive structure allows for quick adoption and mandatory implementation of new standards at home, which speeds up the learning curve and provides the perfect testing ground before you try to go global.
Which means the fundamental question of governance itself, how a society organizes itself to make decisions, is now being tested on the global stage of technical protocols. Which institutional grammar is better adapted to legislate the future? Is it the friction-heavy, deliberative model, or is it the efficient, centralized, long-term planning model?
I think the race for standards dominance is the clearest possible manifestation of that very competition. The success of a plan like Standards 2035 is entirely dependent on the institutional ability to ensure that all national resources, academic, industrial, and diplomatic, are pulling in the exact same direction consistently for 15 or 20 years.
And that consistent, coordinated effort is the ultimate competitive advantage in defining this new technical reality. It allows the national industrial base to act as a single, unified entity on the global stage. #outro. So we started with that stunned realization in a California boardroom. That shock of seeing the technical blueprint for your own revolutionary device was actually written by your competitors.
And we've traced that realization all the way back through industrial capacity, educational policy, and ultimately to institutional design.
I think we've established that these international technical protocols are now the essential legislative field for global power. This dominance in standards is built on a rigorous, decades-long national strategy. The Standards 2035 blueprint, which leverages industrial mastery to create global influence.
And that strategy, in turn, is powered by an extreme, systematic industrial efficiency. That efficiency is cultivated by widespread, applied technical education and R&D spending that's focused on diffusion, not just discovery.
Right. This institutional capacity is what allows the state to convert lab output directly into scalable supply chain controlling standards.
And that capability is then exported through foreign policy integration, like the Digital Silk Road, which embeds compliant technology and standards in partner countries by making them the most attractive economic choice. The standards become the silent operating system for a huge portion of the emerging global digital infrastructure.
The power shift really is undeniable. The power to write the rules, the fundamental grammar that defines the future of all technology, is derived from the systematic efficiency and a unified institutional capacity. And that power feels much more permanent, more pervasive than just the ability to brand or assemble a final product.
I think that's right. The most important asset in the modern economy may no longer be proprietary software or physical hardware. It's the institutional ability to establish the neutral language in which all future technology must communicate to exist.